different example here. It says let f of x equals 2x minus 2, and where we are going to graph g of x, which is 2 times f of x. So that means we're going to multiply the whole equation by 2. That means I'm going to multiply this 2x by 2 to get 4x, and I'm multiplying 2 by this negative 2. It's going to give me negative 4. So just that idea. All right, so let's take a look at what the transformation is. So I'm going to go ahead and look at my chart here. So in order, I'm going to do 2 times f of x. So that number is greater than 1 and multiplying the whole thing. So this has to be the 1. All right, so in that case, this is going to be a vertical stretch. By a scale factor of 2. So remember when we did dilations last year, you're doubling it to make it bigger by 2. So this one's a little bit tricky because we're going to actually make a table to figure this one out. But we're going to go ahead and graph the original equation first. So negative 2, and the slope is up 2 over 1. Or down to the left one. Okay, that is my f of x. All right, so since I have that graph, I'm going to make a table that represents the points on f of x. Okay, so I'm going to make x and f of x. That's your y coordinate. So x coordinate, y coordinate. So I can just look at my graph that I just did. So when x is negative 1, my y would be 1, 2, 3, 4, negative 4. I'm just going to pick a couple of points. So when x is 0, f of x is negative 2, and I'm just going to pick 1. Let's do 2 more. And then when x is 1, f of x is 0, and then I have 2 and 2. We do 2 points there. Cool. All right. Now, in order to get g of x states that if I want to get g of x, I have to double whatever f of x is. Okay? I have to double it, multiply it by f of x. So that means I'm going to go ahead and change my pen here to like a red one. So in order for me to get g of x, right, I had to double it. I had to multiply f of x by 2. So I'm going to take negative 4 and multiply by 2, and that gives me negative 8. Negative 2 times 2 is negative 4. And 0 times 2 is 0. And 2 times 2 is 4. So when I'm going to plot this point, but I'm going to use the x coordinate, my original x coordinate, and I'm also going to use g of x. So I'm going to go ahead and graph this by using this right here as my x coordinate and that row for my y coordinate. So I'm going to have negative 1 and negative 8. Let's see if I can do that. Negative 1, negative 8, 1, 2, 3. It's a little bit off, but there it is. That's 1 point. And then I have 0. The x is 0. My g of x is now negative 4. So 0, negative 4. And I have 1 and 0. Same point right there. And I have 2 and 4. And that is a vertical stretch by scale factor of 2. Essentially, we're just making the line more steep or steeper. Okay, so this is your g of x. 2 times f of x. All right, to solve this algebraically, I'm going to show you right here on the side. I'm going to try my best. All right, I have g of x equals 2 times f of x. So whatever f of x is, which is 2x minus 2, we'll multiply the whole thing by 2. And we're going to check to see if we did it correctly. So 2, f of x is 2x minus 2. So 2x minus 2 So g of x is equal to 4x minus 2. Okay, so let's check our graph that we did when we actually did it from a table. So let's see if that works. Oopsie, this should be -4. My bad, -4. All right, so 4x minus 4. So I'm going to go ahead and look on my graph and go down 1, 2, 3, 4. Oh, yep, there goes my y-intercept. And my slope is 4 over 1. So up 1, 2, 3, 4 to the right 1. Up 4 to the right 1. So we did our equation right, which is, don't mind my scribbleness, 4x minus 4 is what g of x is.